Problem number 707, design linked list. Design your implementation of the linked list. You can choose to use a singly or doubly linked list. A node in a singly linked list should have two attributes, value and next. Value is the value of the current node, and next is a pointer reference to the next node. If you want to use the doubly linked list, you will need one more attribute, prev, to indicate the previous node in the linked list. Assume all nodes in the linked list are zero index. Implement the myLinkedList class. MyLinkedList parentheses initiates the myLinkedList object. Int get, int index, get the value of the index node in the linked list. If the index is invalid, return -1. Void add head int value, add a node of value val for the first element of the linked list. After the insertion, the new node will be the first node of the linked list. Void add tail int value, append a node of value val as the last element of the linked list. Void add indexed int index int value, add a node of value val before the index node in the linked list. If index equals the length of the linked list, a node will be appended to the end of the linked list. If index is greater than the length, the node will not be inserted. Void delete at index int index, delete the index node in the linked list if the index is valid. Okay. Please do not use built-in. Okay, at most 2,000 calls will be made to get. Okay, so for get the value of the index node in the linked list. Okay, I came up with I think, yeah, I will need like the head of the linked list, head, and also tail of the linked list. Oh, maybe and the length of the linked list. Yeah, so for length, then I can quickly know if like this add index or delete at index, if these index are valid or not. And yeah, for head and tail, I can use for add and tail to quickly to quickly know to quickly add a node and add tail, and also add head. So yeah, this will be O1. Let me see. Yeah, add head will be O1, and add tail will be O1 as well. Time complexity will be O1. Have time. And can first check if index smaller than length n. As well as yeah, smaller or equal, because if index equals the length of the linked list, it will be appended at the end. Yeah, some optimization like index, if index valid, index equals 0 or 0, then we can call add head, and index index equals index equals n, then we can call add tail. Others we will do like yeah, we will do a loop. Yeah, same as get, like we'll have a index, we'll have a and we'll have an index counter. So when index counter equals index, yeah, we will have a while loop. So while okay, we'll have an index counter and the current pointer, and if it will have a while loop while index counter equals smaller than index, then we will have current equals current next, and after we exit the while loop, then index counter will be equal to index, then we will index counter plus 1, and then after that we will add a node like current next equals we need to create a linked list. Oh, link, like a link. Then we can have a linked node with value, yeah, and current equals current next, and we will have to we will first have to store the next value of that next node of current next, and then we'll assign current next to a new node. Then we'll have to merge them together, so merge them back, so current will be current next and current next will be next. Not sure if we, okay, I think we don't have a linked list, linked node, so maybe we have to define ourselves like class linked node. And self value equals 0, next equals default to none, and self value is value, self next is next. Okay. So let's implement this. Okay, we think we can implement at the head first. So we will have, implement init first, sorry. So well, self, then self, then is 0, self had equals none, self tell equals none, okay, so at head, I think there are two situations, like if head, then we can create a node with value and assign its next to head. Oh, then we don't need to check if head exists. So we can have like node equals this linked node value, and node next will be self head. Then self, we should change self head will be node, tell will be the last node, the first node. solve then 4 plus 1. For tell, okay, for tell, I think there are two situations. Like if dense is 0, then it's none. And for tell 1 had length is 0, then tell is none first, then after adding we should head is also tell. Okay, and number 2 situation is length larger than 0. When it is larger than 0, tell will not change. Okay, so if length is equal to 0, tell will be had. Okay. Then add a tell. We will have, I think it's similar to this function, just change tell to head. So node will be linked node value, then or we'll have solve. Okay, then we have to check if tell exists, then tell next equal to node. Else solve had equal to solve tell equal to node. If tell next equal to node, and we will update solve tell equal to solve tell next. Else solve had equal to solve tell equal to node. And then we should Oh yeah, for both situation, lens should all plus one. So yeah, we'll have self. Oh, we haven't updated the head. Oh, okay, head will not change for this, and lens, yeah, lens will be updated here. So lens plus one. Okay. And okay, before that, I think it will be O index, like see which index it gave. Yeah, for time complexity. And it will not be larger than n. So check first. Check if index if smaller than n. If okay, else return -1, and then yeah, like increment will be index smaller than self, then I'll say larger or equal to self lens, then return -1. Then we will have to traverse the linked list and also count the index, and yeah, if the index count equals index, then we will return the value. Okay, so we will have a pointer. So pointer, current is the pointer, and it will be the head. Yeah, I'm thinking of edge cases, like if there is empty, if empty, then if this is 0, okay, then it will return -1. Okay, so current, okay, this will not, yeah, this will always have value. So current will be self head at default, and we'll have current index equals 0, since head will be 0. So while or maybe yeah, we can use a for loop, like for loop in range. Yeah, then we don't need this. Like we will do, if index 0, we will have to run 1 time. Oh, no need. And if index 1, we need to run 1 time. Yeah, so we can put index here, and current will be current next, we'll traverse and return current value. Okay, and then maybe let's try run like that. So for example, now we have, we just try run n equals 0 and index is 0, then it will return -1. Okay, and what if n length is like 2 and index is 1? Okay, then we will have head and tail, different nodes. Length will be 2. So current node will be self head. For run index is 1. So we will run 0 one time. Then it will move from self head to tail. So it will return the value of tail. Yes, correct, because 1 is the second node of the linked list. Yeah. Okay. Okay, we have 2 more functions to implement. Okay, let's first check. I think we can copy this. Like, okay, let's see. The instructions that if index greater than the length, the node will not be inserted. So do nothing. So return, just return. Then we can add an index. So we will have to be the index before the index that we want to add. Okay, let's first make the node value. Okay, and then we can also use this. The current start with head, and then we will I think we should run like if we have length 2 and index is, we will add index at 0, then I think, like what if index is 0, then we should add a dummy node. So I will have it like dummy and this node, a linked node. What is we are, let's say list node. And this next will be self head. So for then current will end it at the index before, so we can do adding. And we will run index time. Like if this is 0, we will not run. Then and if correct, we don't have to move. Then if this is 1, we will have to move 1, and we will end it at index 0. the node index, the index 0 node, and we can do insertion, then assign next to the next value to the original index 1 node. Yeah, so okay. Then we will do insertion here. I will move node here. Let's say insertion. Current next equals, we'll have to save the next first. Current next, since this next value should be added after insertion. Okay, and then we assign current next to the new node, and current equals current next, then current next. Yeah, we can, there is oh, we can have it like this. Yeah, we can have next equals current next, I think it will be, yeah, we'll have like this next, and then current next will be node yeah, and then we'll finish. Do not, it's not necessary to return. Okay, and then let's do, oh, we need, yeah, we have to update the head and those stuff. Okay, if okay, oh yeah, we can do this if, then if index equals 0, then we will do self add head, value, return. Oh, and we have to yeah, it will update the head. Okay, and then if index equals, oh, yeah, this should be larger than, because we can accept equal. If index equal to length, then it's, yeah, it's this condition, like, then we will do add tail, value, return. And for this other situation, we will just, yeah, it will be adding in the middle, and we will just update our length. Okay, and then we will see deletion for the deletion. Okay, check index again. If index larger or equal to length, then it's invalid, just return. And yeah, we need a dummy node to deal with the situation that the head will be deleted. So this node next solve head. And okay, so we will also need to be at the previous index of the deleted index. So yeah, we will do the same thing like for in range index, and parent will be parent x. And then here we will do the deletion. When we arrive at the index before the deleted index, then you will have next value to first no, we don't need next because so current next will be current next. Yeah, and then solve length -1. I think we can try run insertion and deletion. Yeah, for example, like maybe deletion, like we have a length of 3, and it will be like let's say 5, 4, 8. Okay, so maybe we'll start from insert add. So we have an empty instance, linked list instance, and then we will call add at index. We call like index 0 value, index 0 value 5. So index 0 is larger than length. Okay, default situation is length equal to 0. Okay, so index is larger now, so we will have entered here index equals 0. We will call add head. So for head, we have 0, 5 value. So node will create a node for value 5, and node next will be head. You can write it like next equals yeah. And then yeah, like this. So head is now 5, and length length is 0 before, then tail will be equal to head is 5, and then will be added by 1. And then we can add we can add 1, 4. So if index equals length is 1, no, length is 1, it has 5. Then yeah, so we will have self add at tail, so 4, and tail has value, so we will have tail next equals 4. Okay, and tail will now be the next, yeah, it will be 4. And that's 4 plus 1, so it's 2 now. Then we will have add 1, 8. Okay, so index not 0, index is not larger than length, index is not equal to length, so we will have here dummy node will be 5. Okay, we'll have a dummy node here. So okay, so for this for loop we will run 1 time. Yeah, since range will be 1, so we'll run 1 time with like 0 here. Running 1 time, we will be ending at current will be pointing at 5. And then next is 4. So node will be 8 with 4 pointing to 4. And then current next will be, yeah, we're standing at 5. Its next will be pointing to the new node. Then self length will be added by 1, 3, and it will be like 8. Yeah. I want to check here, like, yeah, at head. So for example, we have length is 1, we have like 2, so add another value, we will have had like 3, it will create a value with 3 and pointing to 2. It's our new node, so had will be the new node. Yeah, makes sense. Okay. And let's delete this one. So call delete, maybe add 2. If in 2 larger or equal, no. Length is 3, so we are not larger, and yeah, we will create a dummy node. Yeah, this we don't need this. Okay. Okay, dummy is not needed. So delete 2, then index 2, we will delete 4. So we'll have a dummy node, and then it's next. Okay, next I will be pointing to 5. So 2, we will run 2 times for this current 0. For this, it will be 0 and 1. So we are at the dummy node here, and then for 1 iteration we will move to 5, and then for the next iteration we will move to 8, and then we will finish the for loop. We will move on to the deletion, so the current will be pointing to 8, so its next will be the next, then the next. So yeah, it will be 4th next, and it will be none. So yeah, this will be deleted to none, and then we will minus the length to 2. Okay, so I think it's done. Let's run. Oh, okay, there will be stupid mistakes. Okay, let's check if any missing, like this node, and check if any okay, I think there's no missing. Oh. Get add had 1. So at till 3 at index 1. So it will be 1, 2, 3. Delete 1, 3. Okay, something went wrong here. Like, okay, let's check if at had one. Okay, this is 0. And at had 1, we will have 1. Okay, node 1. Next will be none. And then the head will be node. So if self done is 0, yes. Self tell will be self head, correct. Self done will be added by 1, so this will be 1. So we have now this, and we will have at tell 3. So we will have a node with 3, and self tell, if self tell, yes, self tell next, tell is 1, so self tell next will be 3, and self tell will move to here, yeah, and length will be added by 1, it's 2. And then it will be add at index. Add at index 1, 2. So let's do index 1. Okay, so we will not enter this, not enter this, we will not enter this. We'll start here. This node is had next. Okay, we have a dummy node, and then we will start from, we'll run one time for like this is 0, so it will be current will be pointing to 1, and then for the insertion, next is 3, and we will have create a list node that is 2 with next value 3, and we will have current next. This will be deleted, yeah, and it will be pointing to this. Oh, we did not update it. Did we tell? Like before tell is 3. Yeah, so we don't need to update. And then get 0. Oh yeah, get 1. 1, we will have get 1. Then we will have index, that is 3. We forgot to, yeah, there is tens plus 1, so it's 3, and yeah, this 3, and then get 1. Current will be had, so it's 1, and then 1 we will, for range 1 we will run one time, so we will be here, current will be pointing to 2, and we will return 2. Correct. Then time for delete at index. Delete at index 0. We will have this. So index is 0 is not larger, okay. Then we will have dummy node pointing to next pointing to 1. And 0 we will not run. So yeah, current next will be current next. So like head is changed. Okay, and tail will change if we delete the tail node. So if index is 0, then self head will be current next. If yeah, and then if index equals self length minus 1, then self if we delete this, if delete 2, then 2, then we will have 2 times 1, 2 standing at here. So tail will be current. Yeah, we will delete 3. Okay, that's wrong. Oh. Yeah, I want to create another test case, like this is 2. Okay, great.